Have you ever wondered if there is an opposite to a black hole in the universe? Our universe is a vast, mysterious expanse, brimming with enigmatic phenomena that continue to baffle even the most brilliant minds. In this grand cosmic play, black holes have long been the enigmatic villains, swallowing everything that dares to cross their path, even light itself. But what if I told you that there might be a cosmic counterpart, a mirror image to these voracious monsters, an entity that, instead of devouring everything in its path, spews out matter and energy? Sounds like science fiction, doesn't it? But the universe has a knack for making fiction seem plausible. Just imagine if such a celestial body existed. It would turn our understanding of the cosmos on its head. A cosmic force that could challenge the insatiable appetite of a black hole, reversing its all-consuming nature and potentially providing us with an endless source of energy and matter. This is no ordinary thought experiment. It's a question that has been tickling the minds of physicists and astronomers for decades. A question that has led to countless theories, debates, and even heated arguments in the scientific community. And what's more, this isn't just a wild hypothesis. There are hints scattered throughout our understanding of the laws of physics that suggest the existence of such an entity. Tiny breadcrumbs in the grand cosmic story that may lead us to one of the greatest discoveries in the history of science. But before we get ahead of ourselves, let's take a step back and look at what we know. Black holes, these incomprehensible cosmic vacuums, are a well-established part of our cosmic understanding. They are the embodiment of extreme gravity, a place where space and time warp and twist into a singularity of infinite density. But could there be an opposite to this? A place where matter and energy burst forth rather than being swallowed? Well, you might be surprised to know that such an opposite does exist. They are known as white holes. Now, what exactly are these white holes? While the mysteries of the universe may seem infinite, understanding white holes is a step toward untangling the cosmic web. Let's start at the beginning. The term white hole is derived from its more famous cousin, the black hole. While the latter is a region in space where nothing can escape, not even light, a white hole is quite the opposite. Picture it as the mirror image of a black hole, a region of space that cannot be entered but from which matter and light can escape. So, how does a white hole work? Well, it's a bit of a mind-bender. Theoretically, white holes are solutions to the equations of Einstein's theory of general relativity, just like black holes. But unlike black holes, which pull in all surrounding matter, white holes supposedly spit out matter. They're like cosmic fountains spewing out whatever they might contain. Now, you might be wondering what's inside a white hole. The answer is we don't know. While we've identified black holes in our universe, white holes remain purely theoretical. We've yet to observe one directly. Some scientists speculate they could be the other end of a black hole, a sort of exit point in another universe. But for now, that's pure speculation. So what makes white holes different from black holes? The key difference lies in their event horizons. An event horizon is a boundary in space-time beyond which events cannot affect an outside observer. For a black hole, the event horizon is a point of no return. Once crossed, there's no going back. But for a white hole, the event horizon is a point of no entry. Nothing from our universe can go in. So, in essence, while a black hole sucks everything in, a white hole is a region of space that cannot be entered but from which matter and light may escape. In this cosmic dance, black holes and white holes serve as fascinating partners, each a mirror reflection of the other, yet fundamentally different in their nature. But if white holes exist, why haven't we seen one? This question takes us into the paradoxical realm of white holes. While black holes, their cosmic counterparts, are detectable through their gravitational pull and the effects they have on surrounding matter, white holes are quite the opposite. They are theoretical objects that are essentially black holes running in reverse, spewing out matter and energy rather than sucking it in. To understand the paradox, let's first consider the concept of time. Theoretically, white holes exist at the end of a black hole's lifespan. But given that we perceive time in a linear fashion and black holes are incredibly long-lived, we'd have to wait an astronomical amount of time before a black hole could potentially transform into a white hole. Additionally, white holes are predicted to be highly unstable. Even a tiny particle entering a white hole could cause it to collapse. This makes the likelihood of observing a pristine, undisturbed white hole extremely low. Moreover, the very nature of white holes could make them undetectable to our current means of observation. while black holes create a distinct shadow or silhouette against the cosmic microwave background radiation. White holes spewing energy and matter might just appear as another bright celestial object. In the vast expanse of the cosmos, distinguishing a white hole from a star or a quasar is like finding a specific grain of sand on a beach. Lastly, our understanding of white holes comes from the mathematical solutions of Einstein's general relativity equations. But these equations don't account for quantum effects, which become crucial at the heart of a black hole or a white hole. Quantum gravity, a theory that could potentially bridge this gap, is still under development. So while the existence of white holes is a tantalizing idea, their inherent instability, our linear perception of time, their potential indistinguishability, and the limitations of our current scientific understanding all contribute to the paradox of their observation. The paradox of white holes is a fascinating topic that continues to perplex scientists. So, what role do white holes play in our universe? Well, let's dive into the cosmos and speculate. You see, white holes, much like their black hole counterparts, are primarily theoretical. They're derived from the equations of Einstein's theory of general relativity. But unlike black holes, which devour everything, white holes are theoretically spewing out energy and matter. So how could these cosmic fountains fit into our universe's grand tapestry? One intriguing theory suggests that white holes could have played a pivotal role in the very birth of our universe. Yes, you heard it right, the Big Bang itself. Some scientists propose that our universe might have been born from a white hole, a cosmic seed that sprouted and expanded to create everything we see around us today. Fascinating, isn't it? But the theories don't stop there. White holes might also be key players in the mysterious realm of dark matter. We know that dark matter makes up about 85% of the universe's matter, yet we can't see it, touch it, or detect it directly. So, could white holes be the elusive sources of dark matter? It's a possibility. If white holes are spewing out matter and energy, perhaps some of that matter is the dark matter we've been searching for. It's also worth noting that white holes could potentially be time's mirror image of black holes, offering a fascinating perspective on the nature of time and space. If black holes represent the past and white holes the future, then maybe they're two sides of the same cosmic coin, each playing their part in the universe's constant cycle of creation and destruction. Remember, these are just theories, and we're still far from confirming the existence of white holes. But isn't it thrilling to ponder over such cosmic mysteries? The potential roles of white holes in our universe are as intriguing as they are diverse. To wrap things up, let's summarize what we've learned about white holes. These fascinating celestial bodies, purely theoretical as of now, are the exact opposites of the black holes we're more familiar with. Where a black hole gulps matter and light, a white hole does the exact opposite. It spews out matter and light, refusing to let anything in. We've explored the paradox of white holes, a conundrum that boggles the minds of even the most seasoned physicists. The laws of physics as we understand them today predict the existence of these white holes. However, we're yet to observe one in the observable universe. This paradox is a stark reminder that our understanding of the cosmos is still in its infancy, and there's so much more left to discover. We've also delved into the potential roles white holes could play in the universe. They could be the birthplaces of new universes, creating a multiverse where our universe is just one among many. They could also be the endpoints of black holes, where all the matter and energy consumed by black holes is expelled into another universe or another time. These are fascinating concepts that could fundamentally change our understanding of reality. Yet, despite our best efforts, white holes remain elusive. They're like the ghost particles of the cosmos, predicted by our equations but invisible to our telescopes. They represent the frontier of our knowledge, the edge of our understanding, the limit of what we can comprehend with our current tools and theories. And so, as we continue to explore the vastness of our universe, the enigma of white holes remains one of the most captivating mysteries yet to be unraveled. These celestial specters continue to inspire us, driving us to question, to explore, and to push the boundaries of our understanding. In the grand cosmic puzzle, white holes are a piece that we're still struggling to place.